Hello students, in this video we are going to explain the applications of back bonding. Back bonding influence bond length, shape of the molecule, acidic nature, bond angle, formation of adduct. It also influence bond length, shape, acidic nature, bond angle and formation of adduct. The first one is bond length. Bond length is influenced by the back bonding. Let us take BF3 molecule, BF4 minus molecule, BF3 molecule, BF4 minus molecule, BCl4 minus or species, BCl4 minus species. In this one, in BF3, there is back bonding between vacant 2 orbital of boron and complete filled 2p orbital of fluorine. Thus back bonding is found in this one. In this case, there is 1, 2, 3, 4 bonds are in this species. Of course, this is having negative charge. Now in this also there are 4 bonds. There are 4 bonds between that is boron and chlorine atoms. Clearly. Now because of back bonding, the BF bond length is lower. This is lower than ordinary BF bond length and BCl bond length. So it has least one. BF3 has least bond length compared to these two. Now we have to discuss about bond length of these two. Now as this is a very small atom and this is a larger atom, in case these two, BF is smaller in case of BF, bond length is smaller in case of BF compared to BCl. So this is the order of bond length. It is the order of bond length. Second application, we are taking the bond length of BO3 minus molecule, BOH4 minus molecule, BO3 minus species, BOH4 minus species, and also that is BOH thrice species. Okay. Now in this one we are going to discuss the bond length. Now in this one, that is boron is held with 3 O minus ions. In this one boron is held with 4 OH groups. There are 4 OH groups. In this one, that is 1, 2, 3 OH groups. Okay. Now when we take this one, boron made 3 bonding, 2s1, 2p1, 2p1, still it is having vacant orbital. To this vacant orbital, the oxide ion donate lone pair of electrons. And interesting is boron 2 second period element, oxygen is also second period element. There will be back bonding between second period and second period atom. One has lone pair and another one has bond pair. Similarly, here also back bonding is found. Okay. Whereas in this one back bonding is not possible because already that is all orbitals are used for bonding. These are also used for bonding by OH. This is a kind of already it is a kind of dative bond. Here back bonding is not found in this one. That's why because of no back bonding, the BO length is larger in BOH4 minus. This is larger in this one. Okay, of all these two, this is larger one. In case of these two, that is back bonding is there. But back bonding is more effective by negative charged species compared to the neutral charged atom. That's why it is very least in BO3 minus compared to BOH taken thrice. So this is the order of BO bond length. I will explain once again. it has no back bonding, so larger BO bond length, whereas in these two cases back bonding is found. Here back bonding is between negative charged atom and boron atom. Here neutral atom and neutral atom and boron atom. Negative charged atom can make effective back bonding. Here more effective back bonding, more effective back bonding, whereas here less effective back bonding, that's why this is the bond length order. Clear? Now next one we are going to explain another application that is shape of larger molecule or species. Now shape. Second one, I am taking NCH3 taken thrice and NSiH3 taken thrice. Now this has pyramidal shape. This is also having pyramidal. We expect, but actually this is not pyramidal shape. For what reason? Of course, both have bonding like this: single bond, lone pair. Whereas in this case also the bonding is like this. Of course, it is also having the lone pair of electrons on the central atom. Now, why do it is having only pyramidal shape, whereas the shape is changed? For what reason? Now you examine. In nitrogen there is lone pair of electrons, and one more point is carbon has no vacant orbital. Carbon used 2s1, 2p1, 2p1, 2p1. There is no 2d orbital. That's why here no back bonding. In this case there is no back bonding. Between nitrogen and carbon, because carbon has no vacant orbital. Whereas in between nitrogen and silicon there will be formation of back bonding, because I told you silicon has 3s1, 3p1, 3p1, 3p1. Still it is having vacant 3d orbital. It has lone pair in 2p, so 2p can overlap with a vacant 3d orbital. Thus back bonding is possible. Because of the back bonding, the shape changes into trigonal planar. Because of this one, the shape changes to trigonal planar. So it is not have the pyramidal shape. The shape of this species is trigonal planar. Because of back bonding, the angle also increased. Actually this is expected to be 107 or 108 nearly, whereas this is more than 108. Thus the shape is influenced by back bonding. Clear? The next one is next application, bond angle. Bond angle is also influenced by the back bonding. Bond angle is influenced by the back bonding like this. Now we take one example. Third application is bond angle. Now you take water molecule and Cl2O molecule. In this one, oxygen is the central atom, makes single bond. Still it has lone pair of electrons. Now central atom makes the single bond, lone pair of electrons. Clear? Now what about the hydrogen? Hydrogen has no lone pair or no vacant orbital. There is no vacant orbital. That's why no back bonding in water molecule. No back bonding. Whereas I told you chlorine has lone pair as well as 3d vacant orbital. So it has lone pair in 2p orbital. 2p can overlap with vacant 3d orbital. Thus back bonding is possible. Back bonding is possible. So because of back bonding, that is the bond angle changes to 111 degrees. It increases to 111. Actually for sp3, because it has two lone pair and two bond pair, 2 plus 2 means 4. 4 means sp3. sp3 means 109 degrees and 28 minutes we expect. But because of back bonding, the angle is increased to 111. 111. Of course, it has also 2 lone pair and 2 bond pairs. Totally 4. 4 means sp3. Bond angle is expected to close to 109 degrees. Both have sp3 monoatomic bonded atoms, but this cannot form the back bond, whereas this can form the back bonding. So because of back bonding, bond angle is increased. The bond angle is increased. Similarly we take NCl3 and NF3. NCl3 and NF3. Now N 1, 2, 3 bonds, 4, 5. Here 1, 2, 3 bonds and 4, 5. Nitrogen atomic number 7. It has 5 valence electrons. 3 are used, 1 lone pair. 3 are used, 1 lone pair. Now which molecule can form the back bond? Nitrogen has lone pair, and I told you chlorine has lone pair as well as vacant orbital. That's why overlapping is expected, back bonding is expected. Whereas fluorine has only lone pair. There is no vacant p orbital. So here no back bonding. Whereas in this case there is possibility of back bonding. Back bonding is possible. Because of this one, the bond angle is expected as, so it is having, that is bond angle more for this one. Bond angle is higher compared to the bond angle of this one. Thus bond angle is explained on the basis of back bonding. Because of back bonding, the bond angle will increase. Clear? The next one. Now another application is acidic nature. Acidic nature is explained on the basis of back bonding. Let us take the application is acidic nature. Acidic nature or strength. Acidic strength. Now acidic strength is explained. Now we take CHCl3 and CHF3. Which is more acidic? We will explain this one. If this one generate one proton, then it forms CCl3 minus. If this ionizes to give proton, then CF3 minus is formed. Now in this one, which anion is stable? The strength of acid depends upon the stability of anion. More stable anion is more acidic. Less stable anion is less stable anion can form weak acid. Now we explain the back bonding or the structure of this one. It has lone pair or negative charge, whereas this one has lone pair due to of negative charge. Now which species can form the back bond? Now it has lone pair, and you know chlorine has lone pair as well as 3d vacant orbital. That's why there will be possibility of possibility of back bonding. Whereas in this case there is no vacant d orbital or vacant p orbital. That's why in this case back bonding is not possible. So this is less stable. Whereas this is stabilized by resonance, stabilized by back bonding. So tell me which species is more stable? This is more stable. That's why this is more acidic compared to this one. Thus acidic strength is explained on the basis of back bonding. Another one. Now we take CH3 taken thrice COH, CH3 taken thrice SiOH. Now which is more acidic? Now you split. When this one ionize, it ionizes to give CO minus ion. This ionizes to give CS3SiO minus ion. Now they ionize to give proton and this anion. Now which anion is stable? Now oxygen has lone pair of electrons. It has lone pair of electrons. 4 lone pair of electrons clearly. Now what about carbon? You learned carbon has no vacant orbital. because carbon use 2s1, 2p1, 2p1, 2p1. There is no vacant orbital. So there is no possibility to make a back bonding between these two. No back bonding. There is no back bonding. Whereas in this case, silicon, I told you, silicon has vacant d orbitals. That's why in between oxide and silicon there will be possibility of back bonding. So this is stabilized. It is stabilized by back bonding. It is stabilized by back bonding. As this is more stable, so this readily ionize the proton, readily ionizes the proton and act as strong acid. It act as the strong acid. Thus acidic strength is explained. The last one, acidic Lewis acid strength of trihalides of boron. BF3, BCl3, BBr3 and Bi3. All of them, the boron has vacant orbital, clear? Now, in between boron and fluorine, boron has 2p orbital, fluorine has 2p2 pair of electrons. So there will be overlapping of this one. Whereas in between boron and chlorine, there will be overlapping because chlorine has electrons in 3p orbital. So 3p can overlap easily with 2p. So more effective between 2p compared to 2p 3p. When we go down, that is the back bonding ability decreases. When we move down, back bond ability decreases because they differ much in energy. Here they differ much in energy because that is 2p have nearly same energy, effective overlapping compared to 2p 3p, compared to 2p 4p, compared to 2p 5p. So the ability of back bonding decreases. So this is almost closed. Here this is closed for somewhat. This is somewhat only closed. It is almost empty. So in which one more vacant orbital is available? This one. Compared to this one, So this is the Lewis acid strength. Lewis acidic strength. Thus back bonding influence what? 1. Bond length. Second one, shape. Third one, bond angle. And fourth one, acidic nature. Thank you.